Today we're doing applications of quadratic functions, which is a fancy way of saying word problems. Okay, if you have a quadratic function, it makes a parabola. If you graph a parabola, the vertex is always either the maximum or the minimum of the function, depending if the parabola is opening up or down. So the applications will often ask you to find something about a maximum or a minimum value of the function. So for the first example, it says the function f of t equals negative 16t squared plus 96t plus 2. Remember, f of t is just like y equals. It gives the height in feet of a water balloon t seconds after it's launched. Find the maximum height of the water balloon. After how many seconds does it reach that height? Sketch a graph and label 2 points. Okay. First thing I notice is it asks for maximum height. When it says maximum, and it's a quadratic, they want you to find the vertex. I know it's quadratic because it's something squared. Okay, so my first thing is I'm just going to find the vertex and I'll figure out if I'm answering the question or not. Okay, let's find the vertex. It's in standard form, so we're going to do h equals negative b over 2a. H equals negative, what's b? Let's go back to the beginning. Even though it looks different, it's in standard form. So the a is negative 16. The b is 96 and the c is 2. So negative b over 2 times a. And the numbers look big, but they often come out nicely. 2 times negative 6 is negative 32. Negative 96 divided by negative 32 is 3. Okay, I'm going to go ahead and find the y-coordinate in the vertex, and I'm going to go back, and then I'm going to actually try to see if I've solved the question. That's the x-coordinate or the t-coordinate in this case. To find the y-coordinate, I can do k, or the other way to write this is people say f of 3 because the function is called f of f. Negative 16 times t squared plus 96t plus 2. And then for the t value, I'm plugging in 3. Okay, still respect your order of operations, but yeah, you might want to use a calculator for some of this. 3 times 3 is 9. 96 times 3 is 288. Okay, negative 16 times 9, negative 144. And you can use a calculator or you can do it on the side. And then negative 144 plus 288 is 144 plus another 2 is 146. Okay, now I'm going to go back and read the question to see if I've even solved anything. Okay, the function gives the height in feet of a water balloon. The t is the seconds after it's launched. Find the maximum height of the water balloon at about after how many seconds does it reach the height? So I want the height and I want the seconds. Okay, the x coordinate is like the t coordinate. So when I found this, I actually found the t value. T is the seconds. So this is actually 3 seconds. And when I plugged in 3 seconds into this function, I got the height. So the height is 146. If they give me units for the height, I'm going to write the units. It says what gives the height in feet. So this represents 144 feet. So let me make sure I answered the question. After how many seconds? After 3 seconds. After 3 seconds, and then what else does it want? The maximum height. The max height is 146 feet. If you label the units, it helps keep track of which one's which. Okay, so 3 seconds, 146 feet. Okay, now sketch a graph and label 2 points. I only need to label 2 points. I already know one of the points. One of the points is 3, 146. Okay, and this is a water balloon, so we're going to stay in positive time, so I only need quadrant 1. Okay, this is just a sketch. I don't want to scale to 146, so I'm going to guess where 3 146 is. This is the origin. If I go right 3, I have no idea how far 3 is. I'm going to go up 146. I have no idea how high 146 is. So I'm making it up, and then I'm going to label the point. As long as you label the point, That is good enough for one of the points of the graph. Okay, now the other point that's really easy to graph is the y-intercept. The y-intercept is the c value. In this case, the c value is 2. So the other point that's nice is the y-intercept. The y-intercept is 0, 2. I didn't make a scale, so I'm just going to guess where 0, 2 is. This is 0, 0. If I go up 2, I'm only going to go up a little bit. So maybe 0, 2 is around here. Since there is no scale, you have to label the point. Okay, now I only have 2 points, but I need to sketch a parabola. This is the water balloon, and it's launching. The vertex is the highest point, so it starts here. This is the very highest it goes to, and then it has to go back down. So when you sketch it, it's going to start here. That's the highest point it goes to, and it should go back down, and it should be kind of parabolic, but it is just a sketch. Okay, and that's good enough. Okay, now that you've seen all the steps, let's try one more together, and you can try some more in practice. Okay, a ball is thrown upward from the surface of Mars with an initial velocity of 60 meters per second. The equation for projectile motion on Mars is h of t equals negative 5t squared plus 60t. What is the ball's maximum? I already know that's a vertex. Height above the surface. Sketch a graph and label the y-intercept and maximum point. Okay, so I need to find the maximum, which is the vertex, and then I need to say the height. It doesn't say I need to say what the time is, but to get the height, I need the time. Okay, so maximum vertex. So h equals negative b. What is negative b? Let's label it. You don't have to label it, but it helps me sometimes. So negative 5t squared, a is negative 5, 60t, b is 60. There's no number at the end, so c is 0. So negative b over 2 times a. Okay, I'm going to get 6 for my, it's normally the x, but in this case it's the t. So t is 6. 6, t is the height? No, t is the time. So this is 6 seconds. They don't ask me about the time, so I'm not going to, that's not part of my answer, but I needed to get the height. This should be a positive value because we don't go back in time in this class. So if I get a negative here, I'll stop and check my signs. Okay, I actually want the height. And the height is whatever h of t is. You can say k equals, or you can do h of 6 equals. Whichever way is less confusing to you is what you should do. Okay, and then I'm going to plug my time of 6 into this equation. And then because the numbers are bigger, if you want to use a calculator, you go for it. 60 times 6 is 360. Negative 5 times 36 is 180 plus 360, which is 180. Okay, I'm going to go back and see if I answered the question. Blah, 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 blah. What is the ball's maximum height above the surface? This is the time. This is the height. What are the units on the height? It's not seconds, so it must be meters. Okay, so what was the question? What is the max height? Maximum height is 180 meters. And by answering the question, you understand what number is what. Because if they only asked me for the time, I would have just written this. Okay, now sketch a graph. Label the y-intercept and the maximum point. Okay. Everything is going to be positive in this graph, so quadrant 1. Um, label the y-intercept. What is the y-intercept? The c value. C is 0, so 0, 0. If it's 0, 0, it should be right at the corner. You should still label it, but if it's at 0, 0, you should be able to tell it's 0, 0. Okay, that's the y-intercept. The maximum point is the vertex. The vertex is 6, 180. Because I don't want to scale it, I'm going to label it. If you want to scale it, you don't have to label it, but you have to label your scale. So I'm just going to say, I'm going to go right 6. Maybe that's 6. I'm going to go up 180. Seems pretty high. Okay. Since I have no scale, I have to label the point 6, 180. Okay. And this is a ball being thrown. The ball starts at 0, 0. This is the maximum. So it needs to come back down on the other side. And because it's a quadratic, it should look like a parabola. And we stop it here because once it hits the ground, it should stop going, shouldn't keep burrowing into the ground. Okay, try the practice problems. Check your answers.